All right, so this is a review of what we've covered. So we're given our f of 3, f prime of 3, g of 3, and g prime of 3. Everything at x equals 3, and we're trying to find those values. So what we're going to do is go back through our stuff. And so the first one here we have is f of x plus g of x. This is not multiply. This is not divide. These are just standard stuff. And so these are just limits as h approaches 0, so we're allowed to just take the derivative of each part. So this would become 2 f prime of x plus g prime of x, and that would be the derivative of this. And we're trying to find the derivatives of the following, of all of them. So now if we plug in f prime of 3, and we plug 3 into g prime, we can find their values. So f prime of 3, g prime of 3, and so that would be negative 12 plus 5 is negative 7. So our derivative of this is negative 7. All right, the next one, if you look at it, we do have two x's and they're being multiplied. That would make this a product rule. And so remember, we're still getting used to this. If you already see it, you can go straight for it, but I'm going to write f, and I can't use f here because we already have an f. So why don't we do a equals x squared and b equals f of x. And so a prime would be 2x, and b prime would be f prime of x. And so for our product rule, it's this one times this one first. So that would be 2x times f of x plus f prime of x times x squared. And so it's the same idea as before with product rule. It's derivative of the first times the second plus derivative of the second times the first. And now we can plug everything in. So our x here is 3, and we're doing the derivative of this. So this would be 2, plug in 3 for all of the x's. And the way, again, we could tell this was product rule is it's two x's and they're both being multiplied. So 2 times 3 is 6. F of 3 is 4. F prime of 3 is negative 6. And 3 squared is 9. So this is 24 minus 54. So negative 30 is our derivative. All right, and then the next one is quotient rule, because again, it's two x's, two functions, and they're both being divided. So we have the top and the bottom, and this is just quotient rule. This is g prime of x, f of x, minus f prime of x, g of x, all over f of x squared. It's just the thing is inverted. Okay, so now we're going to plug 3 into each of them, because that's what we're trying to find. And again, we're taking the derivative of this. Okay, so what is g prime of 3? Our g prime of 3 is 5, and our g of 3 is 2. So that's 5, and that's 2. And our f of 3 is 4. And our f prime is negative 6. All right, let's double check these. So f of 3, it's always best to make sure, is 4. G prime is 5. F prime is negative 6. And g is 2. All right, now we just need to simplify. So this is 20 plus 12 over 16. So that's 32 over 16. And so 2. So our derivative is 2. All right, the last one is a little tricky. Not quite, but it's a little tricky. So anytime you see a square, what you always want to remember is that it just means multiply whatever is in there by itself. So it is product rule. And so we're going to be getting f prime of x, f of x, plus f prime of x, f of x. So what it really just becomes is 2 f prime of x, f of x. And this is a little hint of what we're going into later. And it looks like this, which is called chain rule. And we'll get to that when we get to it. So now we just plug it in. And so f of 3 is 4. And f prime is negative 6. So the derivative of our f of x squared at 3 is negative 48. That's negative 24. What happened there? Negative 24 times 2 is negative 48, and there you have it. So we don't actually have to have functions given to us to use derivatives. You just have to look at the rules. So if it's plus, you just take the derivative of the parts. If it's multiply, there's two x's and they're being multiplied. That is product rule. If there's two x's being divided, it is quotient rule. And if you see a square, you can write it twice, and now it's product rule.